Hi everyone, my name is Hassan and in this video we are going to talk about retry pattern. If we take a look at the different cloud design pattern categories and think of what might be the best category to classify or put retry pattern under it, we will not find any category better than reliability category. Because retry pattern helps your application to handle faults differently. Frankly speaking, many applications out there have proper error handling. So in case of any error happen in your application, you are going to catch it, send it to the user, and advising them what they need to do differently. But the question we need to ask ourselves is, does all of these errors really need to go back to the user, or there is a chance for us to catch or handle some of these errors and try them one more time or even few number of times before advising the user that their request has failed? Also, in most cases, when our application tells the user that their request has failed, the only action that the user can do is click the submit button one more time. And this is exactly what this pattern is trying to do, trying to improve the reliability of your application by retrying certain kind of errors, certain number of times, before advising the user that their request has failed. And we are going to see this in more details in this video. Also, it's good to know that circuit breaker pattern is very close to retry pattern in concept and target. Now let's dive into the example to help us understand this better. Let's assume that we have a group of users that are interacting with our service or our system. And let's assume that our system is hosted in Azure App Service. It could be also hosted in any Azure front-facing services like front door, API management, functions app, etc. And let's say that our system is interacting with a SQL database. And this is the architecture of our solution. So far it's reliable and stable, it doesn't have any issues. But every now and then our system experiences high workloads, coming from a large number of requests coming from the users. In a way or another, it's going to affect the database performance. Because we already know that the SQL database has been designed to be as efficient as possible. And it can execute certain number of operations at any point of time. And if we are going to overwhelm the SQL database with too many requests, the SQL engine is going to kill the new operations to allow the SQL engine to have more resources to finish the execution of the operations that are already in progress. So in this case, the SQL is going to respond back with a deadlock exception. And our system has a proper error handling for this kind of exception and is going to send it back to the user, advising the user to try one more time, hoping that in the next try the SQL would be available to execute or finish this request. And what the user is going to do in this case is to send the request one more time by clicking on the submit button. And then in this case, the second retry has succeeded because the SQL engine was available to perform this operation. This is the main concept behind the retry pattern. Sending the request one more time, hoping it's going to succeed in the next retry. But the question we need to ask ourselves here, would it be even better if we handled this exception at the server side or at the system side? So when the SQL sends a deadlock exception to our application will handle this exception and send it one more time to the SQL database, hoping that in the second retry the SQL would be available to finish the execution of our request. This would be way better than sending the deadlock exception to the user or advising the user to try the request again sometime later. This is exactly the core concept of this pattern, and this is how the pattern is improving the reliability of our application. We are filtering out certain kind of errors that we can handle at the application level, and try to execute them one more time against the SQL database or even another API, rather than sending the error to the end user and asking them to perform this action again. However, there are some constraints you need to be aware of and different retry strategies you need to know when you use this pattern. And the first retry strategy we are going to talk about here is cancel strategy. You want your application to kill this operation and send back an exception to the user as soon as possible, because there is no point for retry this failed operation one more time. Usually we use cancel strategy when the faults are not transient, and it's very unlikely for the faults to be succeeded if we repeated it again and again. And the best example I would like to give in this one is the authentication failure. if the user has provided incorrect credentials to our application. Then our application tried to validate these credentials against identity provider, and the identity provider said it's incorrect credentials. There is no point that our system is going to send another retry request to the identity provider, hoping that the identity provider is going to say at some point, yep, this is a correct credentials. The best thing we can do for this kind of error is to kill the operation and save the application resources and send the error back straight to the user, hoping that the second time the user would provide a correct credentials. The second strategy we have in here is retry strategy. And we do this when we have uncommon or rare error, such as a memory error, for example, that is very likely to succeed if we tried it one more time. These kind of errors we need to handle in our application and send the request one more time, hoping it's going to succeed. The main difference between the second strategy here and the third one that we are going to talk about in a minute is the time. In the retry strategy, we are sending the retry request immediately when we get a failure, because it's an uncommon or a rare fault, and it's very likely to succeed if we send it again immediately, once we get the failure. However, in the third strategy, we are going to retry, but after a certain delay of time. And we use this when there is a connectivity or a busy fault, pretty much similar to the database example I was talking about earlier on in this video. And in this strategy, the error is unlikely to be repeated if we waited a little bit of a time before sending another retry request. This is why, and this is the main difference between the third strategy and the second strategy, is the number of time or a period of time that we need to wait before sending another request. Because if we rushed sending the retry request or had an aggressive retry policy, for the database engine, for example, probably the result is going to be the same. If we have received a deadlock exception from the SQL database, and immediately we send another request, another retry request to the SQL server, it's very likely it's going to fail. So we need to wait a little bit of a time before we send the retry request. And this is the main difference between the second strategy, which is retry only, and then the third one, which is retry after delay. Now let's talk about some considerations you need to keep in mind when you use any of these strategies for the retry pattern. And first of all, you need to consider the retry policies as part of your business requirement. It needs to be well communicated to the business stakeholders. Everyone needs to be aware of it. It's not a workaround that you do on your own or under the table to improve the reliability of your application. Also, you need to avoid sending an aggressive retry requests to the target system, hoping that one of them is going to succeed. Actually, you might be doing more harm than good. You might be burning out your application resources by sending too frequent retry requests. Also, you didn't give the target system a chance to recover from the heavy workload that they had. And after sending a certain number of unsuccessful retry requests, you need your application to stop sending any more retry requests, because at that point, it's going to burn the resources. And the best thing you can do in here is to implement the circuit breaker pattern. So after a certain number of unsuccessful retries, you are going to stop your application from sending any more retry requests for a certain point of time, because there is no point for sending these retry requests because the target system is not available or very busy performing other operations. Also, you need to be aware of the kind of operation you are performing the retry request for, whether it's an idempotent operation or not. Generally speaking, idempotent operations are safe to be executed or retried more than once without any problems. But if your operation is not idempotent operation, it might make some problems. For example, if a certain operation is going to send a request to the target and expects a response back, for any reason it didn't receive the response back, then the application will catch it as a fault and will send another retry, which is going to duplicate the request to the target in order to receive a response. And in this case, it's going to be an issue that you need to avoid. Also, you need to be aware of how much time you are going to wait between the different retry requests. You don't want to send an aggressive retry requests. Also, you don't want to wait too much before sending a second retry request. You need to have a balance between both that works well with the type of the exception you are getting. For some exceptions, it's absolutely fine to send another retry request immediately. However, for other type of exceptions, you need to wait a little bit of a time before you send another retry request. Also, you need to consider if you are going to send a retry request for an operation that's part of a transaction. We already know that transaction is all pass, all succeed, or all fail kind of things, like you combine different kind of operations, so all of them can pass or all of them fail at the same time. And you need to avoid sending a retry request for a particular operation that's a part of a transaction, because it might harm the full scope of the transaction. Also, you should only send a retry request when the full context of the operation is understood. Maybe your service is sending another request to another service that's going to perform another actions. And if you kept sending retry requests, your service is going to send another services or another requests to the third-party services, and you have no idea what's happening in there. Definitely you need to test the retry mechanism and making sure it's working under different situations, and you need to log different actions so you can track and investigate these faults or these errors to fix them in future. Now let's see when you should use this pattern for a transient faults. For example, a remote service is not available or database server is very busy executing too many requests. These kinds of faults that are not permanent, and it's very likely to disappear if we send another retry one more time. And we consider these faults called short-lived faults. Now let's see when you shouldn't use this pattern for the long-lasting faults, also for the errors in the business logic. You don't want to send another retry if you already have an error in the business validation layer of your application. If your application has scalability or performance issues, like your application needs to be scaled out or up to the higher tier, and you are trying to avoid this by implementing a retry policy, this is not a good idea to use it, so you should avoid using this pattern if you are aware that your application needs to be scaled to the next tier. This pattern is to solve a certain number of errors. It's not a workaround for scalability concerns. That's all you need to know about this pattern. Now we are coming to the end of this video. I hope now it's clear for you what the retry pattern is about. What are the different retry strategies you can use? What are the differences between them? And in which cases the retry pattern could be beneficial for your system, and in which cases it could make more harm to your application. Also, we talked about when you should use this pattern, when you shouldn't, and the considerations you need to follow when you implement this pattern. I hope you enjoyed this video, and if you have any questions, please put it in the comments below. And thanks for watching.